Letter A. Chosen variable is the group variable, which is length of hair in centimeters. In letter B, make a list of your chosen variable. So the chosen variables are these numbers: 29, 44, 45.72, 30, 44, 17.78, 38.4, 55.98, 60, and another 60 centimeters.
Make a tally from lowest to highest and the number of frequency. This table shows that the variable of x are arranged from lowest to highest number. 17.78 frequency 1, 29 frequency 1, 30 frequency 1, 38.4 frequency 1, 44 frequency 2, 45.72 frequency 1, 55.98 frequency 1, 60 frequency 2.
And for our letter D, compute for the population mean, population variance, and population standard deviation. For our population mean, x is equals to 29, 44, 45.72, 30, 44, 17.78, 38.4, 55.98, 60, and 60. N is equals to 10. And for the mu, we just need to add all the x and then divide it into 10 to get the answer 42.5. And now, let's move to the population variance. So first, we just need to subtract our given x to the population mean or mu, just like this one. Our x is 29 minus the mu, which is 42.5, and it's equal to negative 13.5. Then after we get the answer, negative 13.5 squared is equal to 182.25. Then just repeat all the steps and you'll get the answer. And if you're already done, we have to add this all up from 182.25 to 306.25. And we will get the answer 1775.47. Then divide it into 10. So our population variance is 177.55. And lastly, getting the population standard deviation is very easy because we just need to find the square root of our population variance. So the square root of 177.55 is 13.32.
Here in letter E, we will be able to learn on how to get sample means of our samples. And since we already have 2 as our n, we will only get to combine 2 numbers from our population data, with no repetition of combinations of course. And because we already have our list of samples, we only have to add them all up regardless if n is 2 or not. Then of course don't forget to divide the sum to n, just like getting average. For example, the first one, 17.78 and 29 is equals to 46.78. Then divide it to 2, which is our n, and the answer is 23.39. So the sample mean of 17.78 and 29 is 23.39.
Construct the sampling distribution of the sample means. Sample mean 23.39, frequency 1, probability 1/45. Sample mean 23.89, frequency 1, probability 1/45. Sample mean 28.09, frequency 1, probability 1/45. Sample mean 29.5, frequency 1, probability 1/45. Sample mean 30.89, frequency 2, probability 2/45.
G. Compute for the mean, variance, and standard deviation of the sampling distribution of the sample means. Sampling distribution of the sample means. So, meron po tayo ditong sample mean. Yung probability niya And yung dulo is yung sample mean times yung probability. So, yung first 5 examples po natin dito ay ang probability po nila is 1/45. Dahil isang beses lang sila nag-appear dun sa mga sample means na meron tayo. And yung total natin sa mga sample na yon ay 45, kaya 1/45. So, example ay ito. 23.39 times 1/45 is equals to 0.52. So, lagi po 2 decimal places. Next is 23.89 times 1/45 is equals to 0.53. 28.09 times 1/45 is equals to 0.62. 29.5 times 1/45 is equals to 0.66. 30.89 times 2/45 is equals to 1.37. So, 2/45 po yun dahil dalawang beses nag-appear yung number na yun. Then, itutuloy niyo lang po yun hanggang matapos nyo hanggang dulo. So, meron po tayong total dito, yung probability is 45/45 dahil 45 po yung samples natin. And then, yung total po nung sample mean times probability ay 42.5, which is equal din po siya dun sa ating mean.
So hi guys, I will be discussing the variance of the sample distribution of the sample mean. So paano nga ba natin ito kukunin? So first, gagawin natin is 23.39 minus 42.5. So ang makukuha natin doon is negative 19.11. So kailangan natin itong square. So negative 19.11 squared is equals to 365.19. 365.19 is going to be divided to 1/45. So ang makukuha natin sagot is 8.12. Ganun lang din dito sa second one. So 23.89 minus 42.5 is equals to negative 18.61. Negative 18.61 squared is equals to 346.33. So 346.33 divided by 1/45 is equals to 7.7 or 7.70. So the third one is 28.9. 28.9 minus 42.5 is equals to negative 14.41. Negative 14.41 squared is equals to 207.65. 207.65 divided by 1/45 is equals to 4.61. So the fourth one is 29.5. 29.5 minus 42.5 is equals to negative 13. Negative 13 squared is equals to 169. 169 divided by 1/45 is equals to 3.76. So the last one, 30.89 minus 42.5 is equals to negative 11.61. Negative 11.61 squared is equals to 134.79. 134.79 divided by 2/45 is equals to 5.99.
The sample mean is 42.600 and its probability is 1/45. 42.600 minus the population mean 42.5 is negative 0.44 and the square of 0.44 is 0.19. The probability 1/45 times 0.19 is 0.42 10,000ths. The next sample mean is 42.49 and its probability is 1/45. 42.49 minus 42.5 is negative 0.01 and the square of negative 0.01 is 0.1 10,000ths and the probability 1/45 times 0.1 10,000ths is 0.22 hundred millionths. The next sample means 42.99 hundredths and its probability is 1/45. 42.99 minus 42.5 is 0.49 and the square of 0.49 is 0.24 the probability 1 of 45 times 0.24 is 0.53 10,000ths. The next sample mean is 44, and with a probability of 1 of 45. 44 minus 42.5 is 1.5. The square of 1.5 is 2.25. And the probability 1 of 45 times 2.25 is 0.05 hundredths. The next sample mean is 44.5, and with a probability of 2 over 45. 44.5 minus 42.5 is 2, and the square of 2 is 4. The probability 2 over 45 times 4 is 0.18. The next is 44.86 with a probability of 2 over 45. 44.86 minus 42.5 is 2.36. 2.36 squared is 5.57. The probability 2 over 45 times 5.57 is equals to 0.25. The next is 45 with the probability of 2 over 45. 45 minus 42.5 is 2.5, and 2.5 squared is 6.25. The probability 2 over 45 minus 6.25 is 0.28 hundredths. The next sample mean is 47.19 with a probability of 1 over 45. 47.19 minus 42.5 is 4.69, and the square of 4.69 is 22. 1 over 45 times 22 is 0.49. The next sample mean is 49.2 with a probability of 2 over 45. 42.5 minus 49.2 is equals to 6.7, and the square of 6.7 is 44.89. 2 over 45 times 44.89 is equals to 2. The next sample mean is 49.99 with a probability of 2 over 45. 49.99 minus 42.5 is 7.49, and 7.49 squared is 56.10. 2 over 45 times 56.10 is equals to 2.49. The next sample mean is 50.85 with a probability of 1 over 45. 50.85 minus 42.5 is 8.35. And the square of 8.35 is 69.72. 1 over 45 times 69.72 is 1.55. The next sample mean is 52. 52 has a probability of 4 over 45. 52 minus 42.5 is 9.5, and 9.5 squared is 90.25. 4 over 45 times 90.25 is 8.2 hundredths. The next sample mean is 52.86 with a probability of 2 over 45. 52.86 minus 42.5 is 10.36. 10.36 squared is 107 and 33 hundredths. 2 over 45 times 107.33 hundredths is equals to 4.77. The next sample mean is 57.99 with a probability of 2 over 45. 57.99 minus 42.5 is 15.49. And the square of it is 239.94. 2 over 45 times 239.94 is 10.66 hundredths. And lastly, the sample mean 60 has a probability of 1 over 45. 60 minus 42.5 is 17.5. And the square of 17.5 is 306.25. 1 over 45 times 306.25 is 6.80. And the total of our probability is 45 over 45. And the total is 78.92. Our variance is 78.92. And the standard deviation is the square root of our variance, which is 78.92. And the answer is 8.88.
In letter H, we just construct a histogram for the sampling distribution of the sample means. So here is the probability of each sample mean. In letter I, answer the following questions. In number 1, describe the mean of the sampling distribution of the sample means. It means that the distribution of the sample means will be more or less normal as long as the sample size is large enough. And it depends on how the population is being distributed to know how large of our sample size is needed in order to assume if the sample mean will be normally distributed. Next is number 2. Interpret the standard deviation of the sampling distribution of the sample means. Standard deviation of the sampling distribution for the sample means is considered important because it implies that the sample mean becomes more accurate when it comes in estimating its population mean as the sample size n increases while its standard error will remain constant. And this is possible only if the standard deviation's population increases as well. Number 3. How important sampling distribution in real life? Sampling distribution is important in real life because if we will not go under the process, we will not know if it is equally distributed or what quality lies on it. And a good example of this is cooking.